So we're live. Welcome everybody to this week's Azure and AI Show. We have three new speakers with us this week, and Joseph is here as well. So we're going to start off with Saranga and his session on what's new with MPC. Okay. Also, we have Teresa with his session on from legacy cloud native building scalable, secure, and AI ready applications. Also, Prathap is going to do his session on predictive analytics and smart workflow orchestration on Azure, healthcare to supply chain. So, Saranga, do you want to share your screen there with us?
Yep, I'll do that. So I'm gonna share my entire screen. Yep. And I'll just
there we go. What's new with MCP?
Yep. So I'll give a small introduction. So I'm Suranga. I'm working for a Swedish consultancy firm in Sweden. So I'm working as a consultant in data analytics. And I'm a Sri Lankan, and currently I'm living in Sweden. And also I'm a bit of into Azure side, and I recently got the MCT badge as well. And I did a couple of Microsoft certifications in terms of AI and a lot of other topics as well. So in terms of this topic, what's new with MCP? So MCP is a new. It's like 7 or 8 months old a technology which is came up. It's something like AI, but it's a newer version of whatever the RAG system or the agentic approaches that we are going to talk about. So if it is a normal retrieval augmented generation or a RAG system, so you might know this is like the basic that I'm going to talk to you all about, but I'm going to take this as the introduction, like what is RAG. Like y'all might heard of LLMs. So it could be your GPT models or OpenAI models or Claude models. Nowadays there's a lot of large language models are there in the industry. So if you ask a question saying how much is my last month's sale or something like that, imagine you own a small business and you wanted to ask what is the last month's sale, and so you can't get that particular answer from the chat GPT or Claude or Gemini or whatever it is. But if you want to do that, we need to come up with a small RAG architecture where we need to connect our databases, like especially vector database, and we need to get it. We are doing a semantic search, and we are getting the relevant chunks, and we can connect all of our documents to this vector database and connect it with the LLM model, and then from the LLM model we can get the answer saying it's 200,000 SEK or something like that. So that is the initial thing about the RAG systems. So then I'll talk about the next step, which is called agentic approaches. So you might heard of a lot of agent applications in terms of chat systems. So it's also pretty much same like the RAG systems, but you have a large language model, the same OpenAI or Claude or whatever it is. So the same model is here, and you are asking the same question or advanced question, but you might have some tools in terms of instead of this particular system, which was the RAG system, you have some additional tools as well. Like it could be some Python functions, it could be some APIs connected, and you can generate answers from this particular agentic RAG application. So this is like the very high level very high level details about RAG system as well as the agentic RAG system. So today we are going to talk about MCP. So MCP stands for Model Context Protocol. It's a new technology which came to the industry. So right now from this MCP, let's say if you wanted to ask how much is my last month's sale, the same question, you have the same LLM model, but you have something called MCP servers connected to this particular LLM model, and you're getting the answer based on the MCP servers that which is connected to your machine. So M stands for model. So the same model, the OpenAI model or the Claude or Gemini or whatever it is, the same model is the M or the model. So it's like a client server architecture where server is talking to the client. So the context is you can call many tools or APIs or different softwares in terms of this context, and the overall it's going to be the MCP, which is the model context protocol. So that is bit of about the high level theory of this MCP protocol. So I'll just show you some cool examples in terms of this. So I'll quickly go through my Visual Studio Code. So in here, if I make this large so you all can see it properly. All right, so in here you can see that there's GitHub Copilot is here. So if we click on that, so there could be a small window like this would pop up where you can chat. It should be something like this. Maybe you can turn it like this one. And then I'll just in here, once we click on this particular small tool, you can see all the tools which is available to chat is here. So right now I do have a lot of tools installed in terms of MCP. So I'll just show you some of those things. Since it's Azure AI Show, I'll just turn on Azure MCP as well as the file system. You can plug in. It's like a we call it it's a USB-C drive for your LLM. So you can bring a lot of other tools like Azure MCP or the file system tool, or if you have SQL Server, I have a demo with the Databricks as well. So it's Azure Databricks that we are going to do a small demo about the tools. So there are a lot of, so this Azure MCP is kind of, it's 3 months or 4 months old, but the Databricks MCP is quite new to the industry at the moment. So if I turn on this Azure MCP and file system, and I'm just going to ask, let's see if it is working. Can you list me all the Azure subscriptions that I have? So something like this. So we are asking whether to list all the Azure subscriptions that I have, and the tool that we are going to use is this one, the Azure MCP server. So right now when I type that one, so you can see my whatever the Azure subscription and all of the details are there. So it's not a, if you ask the same question from ChatGPT, it won't give you the your relevant answer that you expect. So likewise, you can connect Azure, whatever the tool which is have the MCP servers available, so you can install it in your computer and ask the question. So as another example, if I ask, can you show me the resource groups that I have in Azure? So not only these things, if you want to create a blob storage, or if you want to create an AI service or whatever it is, so if you tell it, it'll show you, or it'll create all the relevant resources or the artifacts for you, as well as if you wanted to do something in your machine. Let's say if you wanted to create some files in your desktop or downloads folder or things like that, so those things you can do it by using Azure, by using MCP, this file system MCP tool. So likewise, there are a lot of MCP tools are there. So right now I'm going to skip this. So this is like the basic of MCP, but today I just wanted to go through the sorry, not this, but yeah, I wanted to go through Azure Databricks. So if you know, inside Azure you can have a Databricks workspace set up. So right now I'm using Azure Databricks service, and I'm using a trial account. And inside this, I'll start somewhere here. So if I go to this, if I go to Frank's LinkedIn, and he has a nice blog where he writes about Microsoft related things and a lot of other things. So I have gone through this, and I have taken all the posts into one particular file, and I have added that to my Databricks workspace. So if I go to this one, and if I go to Frank's blog, and I just ran a small article scraper. So yeah, I'll just turn on this. Yeah. So I just ran a small web scraping job for the Frank's blog, and you can see there is a lot of nice articles was there in terms of Microsoft Stack and a lot of other things. So I have scraped all those documents, and I'm going to use the same MCP model, which is in Databricks side. So in Databricks, if you go to agents, it is right here. I'll just make it a little bit big. So in terms of AI ML, if you go to agents, and you can go to this, I'll just go to playground. So I just wanted to try things out. So therefore I'm going to use playground. What you have to do is you have to just click on these tools and add a tool. Go to this MCP server, but Databricks MCP service right now, which is for today, it's still in beta version. So there could be some problems here and there, but I have tested this out. So if I search, if I give the Unity catalogs as Frank's blog, and we have articles in there, so I'm going to click confirm, and I can have the same Unity catalog for my vector search as well. So by clicking save, so you can see that the MCP service has been connected to this playground. So whatever the questions that you have that you wanted to ask in terms of Frank's blog, it could give you the answers. So for an example, I'll ask so I'm just asking what is Frank's blog's expertise in which stack or something like that, or the specialization or whatever it is. So based on the documents that we have in the Unity catalog, it will give you the answers that the Azure stack and a lot of the SQL, non-SQL, and NoSQL, and a lot of other things as well. So I'll ask another thing saying, so my question was, what does Frank tells about Microsoft certifications? So it'll search about all these Microsoft related Microsoft certification related blog articles in the Unity catalog, and I hope it'll give you a nice response. Yeah. So whatever the things that he has written, he has explained in very good way. So all the course related details and everything, and so his key takeaways and all of those things has been mentioned here, as well as it will give you the answers as well. So basically, this MCP is something like a in your computer. You can have it like a small tool where if you have ChatGPT or Claude or Microsoft AI tools or whatever it is has been linked with your computer. If you want to plug other tools like Microsoft SQL Server or Databricks, or if you wanted to bring another maybe Word, Excel, or Google or whatever it is, if you wanted to get those tools inside whatever your ChatGPT or Claude environments, so MCP is the tool that you should try out. Yeah. So that's what I wanted to share. And
Yeah, it looks very impressive. Yeah, that you can kind of just go on and scrape a whole website and then just get what you want out of it. Like, it's very good,
I just scraped a little bit of maybe there was around a lot of articles, but I couldn't scrape all of it. But it was a really nice blog. If there's time to read it, I would recommend everyone to go and read it if there's time.
Thanks very much. Anybody, any questions? No questions. No questions coming in from the audience anyway. But if anybody does have any questions for Saranga, pop them into LinkedIn, and we'd be happy to help. And once again, thanks very much for a great presentation and interesting stuff. I've never seen it before, so good. And enjoy your birthday.
Yeah, thank you so much.
Okay.
Have a nice time. Thanks, Frank.
Okay. So, Teresa, can you hear me?
Yep, I'm able to hear you now.
Yeah, very good. Do you want to share your screen there with us? So,
yep.
And your session is from legacy to cloud native, building scalable, secure, and AI ready applications.
Yeah.
Looking forward to that. Yes. So when you go to share your screen, you'll get another box that will pop up, and you share entire screen.
Yeah. Okay. I'm trying my screen.
Yeah, this should say share entire screen.
Yeah.
Yeah, I see it there now. Yeah, there we go.
Okay. Give me a minute.
Yeah, there we go.
See my screen? Yeah.
Great.
Okay. Good morning, everyone, and thank you for joining today's session. In this presentation, we are going to explore the journey of legacy systems to modern cloud-native applications, and how this transformation unlocks operational excellence, AI-driven capabilities, and long-term business value. Our goal is to provide a clear, structured understanding of the challenges which organizations face when migrating the applications, the advantages of cloud native adoption, and the practical step required to modernize effectively. So by end of the session, we'll have a comprehensive view of the modernization framework and the key considerations that guide a successful transformation. I'm Surya Prakash. I've been with I'm from India, so I'm currently working in US. So yeah, let's begin. Okay, so the first thing is like I would like to first understand what is the challenges, right? So this slide highlights the core limitations of traditional monolithic systems. The legacy architectures tend to be rigid, making it difficult for our organizations to adapt to evolve business needs. And they also require significant maintenance effort, which diverts resources away from innovation. Um, Integration with modern platforms is often constrained, creating friction when introducing new capabilities. Like additionally, scalability bottlenecks limit to organization's ability and enhancement maintenance ability to grow efficiently. So those are the challenges which highly impacts organization when migrating when working on legacy applications. And also understanding these challenges is essential as they form the foundation or like why modernization is not only beneficial but necessary for long-term competitiveness. So the next one, which would like to talk about is when migrating to a cloud native application. So what are those advantages, right? So cloud native architecture provides a transformative alternative to legacy systems. Microservices enables modular and independently deployable components that increase agility and reduce dependencies. Containerization it ensures consistent environments across development, testing, and production, improving the reliability. And also like adding to that, like if we provide serverless computing, which removes the burden of infrastructure management while optimizing cost and performance. There are like so many small scale applications which is in the org level, which uses the infrastructure, and those infrastructure costs, everything has been can be managed if we go with a serverless computing. And the next thing is like managed services, which helps accelerate our delivery by reducing the operational overhead. So with all these capabilities, which is available in cloud, like it creates a flexible, scalable, and resilient foundation for modern applications, which requires which helps modern applications very stable. So oh, the next thing would be the key benefits of modernization. Why exactly we wanted to do the modernization? So modernizing to cloud native brings several strategic benefits. The first one is like accelerated delivery with continuous integration and deployment pipelines, which enables rapid features, releases, and faster time to market. And then the security. Security is like with built-in controls, automated compliances in cloud native architecture, and zero trust principles that protect critical assets. And the third one is like the reduced complexity, which means like automation can be done very easily, and managed services simplify operations and allow teams to focus on higher value initiatives, which like innovations and everything. And also the other one which I would like to highlight is like um, uh, uh, the availability of the services, right? Like most of the cloud uh, provides us like the availability is 99.99% or greater than. So those are the benefits of modernizing applications in cloud native architecture. Okay, so the end-to-end modernization framework. So our modernization framework follows a structured end-to-end approach. So first, we'd like to begin with assessment and discovery, where we evaluate technical debt, dependencies, and business criticality. So next, we move into the architecture design, defining the appropriate modernization paths and cloud native patterns. We then establish a refactoring strategy, selecting the right transformation approach for each components. Migration execution ensures continuity as workload transition to the cloud. And finally, the optimization and governance, refine performance, cost, and compliance, and also like as I mentioned, like the availability. So this framework ensures a predictable and well-governed transformation journey. Okay. First, as we were talking about the steps, right? Like first step, how we wanted to evaluate the technical debt. So the first step in modernization, as I mentioned, like is a thorough assessment of the technical debt. We analyze code quality, including complexity, maintainability, and test coverage. We map dependencies to identify tightly coupled components and integration points. So performances baselines are established to understand the throughput, latency, and resource utilization. Um, we also assess security vulnerabilities to ensure compliance and reduce risk. So that is a major thing. And this evaluation provides a clear understanding of the current state of the product and informs the prioritization of migrating to a modernization technology as like modernization efforts. Next, as I mean, the next step would be defining which architectural path we wanted to proceed. So once the assessment is complete, we define the appropriate architectural path for each components. Rehosting or lift and shift moves workloads to the clouds with minimal changes, or completely refactoring, like re-architects the component to leverage cloud native capabilities. And also like kind of if we wanted to rebuild and redesign and implement involves redesigning the components using modern frameworks and services. So all these comes under defining the architectural paths. So each component requires a tailored approach based on business value, technical complexity, and strategic importance. So in many cases, currently, like a hybrid strategy delivers the most effective outcome. For example, like database in cloud, or in and servers in on-prem, or like database in on-prem and services in cloud. More kind of more hybrid strategy in nowadays, like it is kind of more common. And then once it would be easier for migrating to more completely to cloud as well. So the next step would be refactoring strategies. Refactoring is the critical part of modernization. So the strangler fit pattern allows us to gradually replace legacy functionality with new services while maintaining the operational continuity, right? So as a user, like we wanted to make sure like we are in the latest, but also it doesn't impact the user. And database decomposition breaks monolithic databases into microservice specific data stores, improving performance and integrity. Like for example, SQL Server to Postgres as a microservice architecture. And API gateway implementation provides a unified entry point for routing, authentication, and rate limiting across distributor services. So these rate strategies enable safe incremental transformation without disrupting business operations. And the migration workflows. So migration requires a structured and controlled workflow. So we begin with environment setup, provisioning cloud infrastructure, networking, and security controls. Next, we conduct a validation and testing to ensure functionality, performance, and integration readiness. A pilot migration follows, allowing us to move non-critical workloads in a controlled manner. And finally, we execute the production cutover, transitioning the live traffic with rollback capabilities in place. This phased approach minimizes risk and supports continuous learning as well. Okay, next come the unlocking AI-driven capabilities. So modern cloud native foundations unlock advanced AI capabilities. Elastic compute enables AI workloads to scale dynamically, and managed AI services provide pre-built models that accelerate development. Also, like real-time data streams supply high-quality inputs for AI systems, and ML ops automates model training, deployment, and monitoring. So together with these capabilities allows the organization to adopt AI at scale and drive meaningful business outcomes. Next, the operational excellence. So the cloud native architecture significantly enhances the operational excellence. It improves the fault tolerance, ensures systems can self-heal and fail over automatically. And as I mentioned, like the availability in cloud is more than 99%. And also like the real-time collaboration enables distributed teams to work seamlessly with shared environments. Automated operations, which includes infrastructure as code, auto scaling, and intelligent monitoring. It reduces manual effort and operational overhead. So these capabilities create a resilient, efficient, and highly available operational environment. Governance and compliance. Governance and compliance are essential components of a sustainable cloud native environment. So when we move to cloud native application, like this is compliance and governance is it's a major thing which we wanted to consider. So an automated policy enforcement ensures adherence to organizational standards and regulatory requirements. And also adding to that, like the cost optimization tool supports monitoring, budgeting, and right sizing to maximize return on investment. So continuous compliance provides automated audit trails and scanning to maintain security and meet obligations. Strong governance ensures long-term operational discipline and accountability when we migrate applications into cloud. Okay, next the measuring success. How do we wanted to, once the application is migrated to cloud, how do we wanted to measure the success? To measure the success of modernization, we evaluate several key metrics. Faster deployment reflects reduced time from code commit to production, and cost savings demonstrate improved efficiency in infrastructure operations, and availability metrics highlight increased uptime through resilient architectures. And also adding to that, innovation velocity measures the rate at which the new features and capabilities are delivered. So these are the common indicators which collectively demonstrate the tangible business value when migrating and when modernizing an application as a cloud native transformation using. Okay. The roadmap to transformation to conclude the framework, right? This slide outlines the key steps in the transformation roadmap. So we begin with the thorough assessment to understand the technical debt and prioritize based on business value and risk. And next, we choose appropriate modernization path aligning strategies with the component complexity and strategic importance. So we migrate incrementally using phased approaches to reduce risk and support continuous learning. And finally, we embed governance to ensure compliance, security, and cost control. So this roadmap provides a structured path toward a successful cloud native transformation. And modernizing to a cloud native architecture is a strategic investment that enhances agility, security, scalability, and innovation. By addressing legacy challenges, adopting modern architectural patterns, and following a structured transformation framework, organizations can unlock significant operational and competitive advantages. So the journey requires a careful planning, discipline, execution, and strong governance. But the long-term benefits are substantial. Thank you for your time, and I'm looking forward for any questions or any discussions.
Very good, very interesting. Um, I suppose the thing is, the amount of savings that can be had in it, from the moving from a kind of capital, buying hardware in-house to just moving it to the cloud it's a no-brainer, really, isn't it?
Sorry, can you, I think, Frank, can you post your question in the chat? Sorry, unfortunately, I'm not able to hear you again.
Yeah, no worries, no worries. No, I just like the part about self-healing systems and automated failover it's a good part. Yeah. So he got logged out there anyway. So Palab, I put your screen up there.
Yes.
Sorry, you got kicked out on us there, Palab. Or
Yes, I put my
yeah, I have it
PDF
there.
in the screen.
Yeah, there you go. I can see your screen now. So the
Yep,
next
yep.
section is predictive analytics and smart workflow
Okay.
orchestration on Azure.
Yes, yes. So,
So
yeah,
just
thank.
before we carry on there, right, there was just one question for our last speaker. I'll just put it up on the screen there. Can you see that?
Yes, yes.
That was so can you see that up on the screen?
Yeah, I'll respond to it. Yeah.
Yeah. Okay. Cool.
Okay. So, let me start. So, my name is Paulo Halda,
Yeah.
and
Can you
today I'm
hold?
going to.
Can you
Am
just?
I audible?
Oh yeah. Just hang on a second there, and Surya is just going to answer that question on the migration.
Sure, sure.
Sure. Okay.
Yes.
Thanks. Okay, so we'll come back to that in a minute. Do you want to carry on there? Sorry, Palab, for interrupting you there.
Yeah, okay. Okay. Hello, everybody.
Sorry.
My name is Paulo Halda.
Sorry, I was
and
talking on mute. So, Frank, can I respond to his question on the chat itself, or do you want me to speak here?
You could speak there. Sorry, no, Palab, for the interrupting. Carry on there. So
No problem.
I'll just put that question up on the screen again. There you go.
Yeah. So one of the most common challenges during migration is the complexity of legacy systems. right? Like many organizations rely on tightly coupled architectures where even small changes can have unintended downstream effects, right? Another challenge is like the data integrity and consistency. So migrating large data set, especially from monolithic databases, it requires careful planning, validation, and sometimes phased out cutovers to avoid disruption. And also, like we need to encounter the gaps in the documentation with the legacy application, which also slow down the assessment of and refactoring process. And the final one is like which we talked about, the security and compliance must be maintained throughout the migration. So overall, these challenges are manageable with the right framework and strong collaboration across technical and business teams.
That's great. Thank you very much.
Yeah.
Okay, Pal, sorry, carry
Yeah,
on. Okay.
yeah. Hello, everybody. My name is Paulo Haldar, and I'm 20 years experience in IT industry. My field of expertise is supply chain management, optimization with enterprise architecture consultant. So today I'm going to discuss about the predictive analytics and smart outflow orchestration on Azure that might affect in the healthcare or supply chain industry, how that is impacting those healthcare industry, and how we can optimize and how we can make better the system, the process. That is all about the integration of the predictive analytics and smart workflow on the Azure interface using. So I'm moving to the next slide. So if you see the presentation, it is clearly mentioned that there is a specific roadmap. The specific roadmap is all about the predictive analytics and smart workflow orchestration on Azure. The first thing, why the predictive analytics is pictured in recent days or now. Okay. So from reactive operation to anticipatory intelligence, apart from this intelligence incorporation, there is several other factors that may picture while we integrate it with the Azure reference architecture. That integration is utilized in different industry. Among those industries, one is healthcare, another is supply chain, which I am going to discuss in depth in my next presentations. So, this predictive analytics, if you see, it enhance the patient care by different kind of optimization from reactive operation and for managing volatility and risk and complexity at different scale. It enhances the patient care. Apart from the patient care, when it integrated with the Azure architectural system, okay, for the execution, so it use is artificial intelligence part to optimize different kind of metrics. One of the metrics is like which I presented in that particular slide is optimized inventory. In the optimized inventory, if you see, there is data data using machine learning, and there is how Azure unifies ingestion, intelligence, and executions. When it is applied to the healthcare industry, if you see the resilient operations that can be carried out in different ways. One of the ways is like reasonable AI, data governance. These are all the steps that is taking picture in the healthcare and the supply chain industry. And it is in enterprise grade security on Azure that is coming picture, which we will discuss in the later section, how it is integrated all over to make the healthcare system better, less risky, and optimized in on a efficient way to make it work better. So I'm moving to the next slide. The next slide is all about why we will use predictive analytics in healthcare system with the AI integration with the Azure. This is one question is arise on everybody. Okay, so to answer this question, so if you see the presentation, I already defined what are the different kind of volatility and uncertainty that may occur in a traditional legacy systems, which is used in the healthcare industry. But if we use the predictive analytics, it shifts from the reactive to proactive decision making so that we can avoid the volatility and uncertainty and unavailability of the product using some supply chain optimization, some medicine that is coming from one industry to another industry, one domain from another domain. So there might be different kind of authorization process, approval process. There's different type of transport and logistics problem. This kind of situation we can avoid. So for that infrastructure, with integrated with the AI Azure, we will define some systems, some optimization, some legacy to overcome those systems. In this presentation, there are some reactive logging like proactive, predictive, and proactive. So there are different kind of process apart from that, like chasing event, demand, and market trends, delayed reaction and disruption. These are the different kind of manual octo batch decision. These are the different kind of process that may lead to volatility and uncertainty in the healthcare industry. So what we will do, we will foresee the risks and opportunities, automate the optimal action using predictive analytics, and continuously learn. It may be the reinforcement learning we will do or adapt learning. Based on that, we will came across different kind of procedure, like we will do some predictive modeling where we the machine learning analyze the data pattern. There might be some predictive models also, like which machine analyze the data pattern, then identify the data insights. What are the data pattern? What it try to remember. That way, we will identify the architectural system structure of the healthcare system data, where it gets stuck in the supply chain of the healthcare. And based on that, using India, there is some predefined features in the Azure, where by integrating with those features, we will integrate those processes and make a optimized system. Now I am moving to the next part, which is the why Azure. Why will use Azure? There is multiple system, other infrastructure, other tool like is there, but if you want to get a inbuilt one type system which is automatically, in out of the box, it is available for to use your predictive analytics, then obviously Azure is the best and suitable architectural system we will use. So I have identified few features and few, productivity element where it's differ from other product that is available in the market. So there one of this is unified platform. So inside the platform, you can integrated different kind of homologous system, heterogeneous system, along with the data synchronization, all thing you can do in a unified platform. The second feature is like stick elastic scalability, where scale resources elastically to meet real-time analytics demand. This is one of the best feature is available inside the AI Azure. And the last one is like the unified platform, which I described. These two integrated to maintain the enterprise security and compliance. So big industries, enterprise system, they should have the security system implemented in a rigorous manner so that the data breach, data compliance never can occur. So for that reason, we have chooses the Azure as our platform, so that in a single integrated system, along with applying the predictive analytics, data model, everything, we can also ensure that the security and compliance will be maintained in a proper efficient way. So that is why Azure is the best in our situation to maintain and apply all that. We selected that as our platform. The next one is the Azure architecture overview. Say all this. This is the common architecture of the Azure. What platform? What we do? Data layer, then ML layer, and then orchestration. Where in the data layer, ingestion and storage, governance of the data comes in picture, and the output is passed through the machine learning layer, where we apply those algorithm and other data metrics over the like dependent variable, independent variable, coefficient factor. These are the different kind of metrics that will be applied to the machine learning layer to get the efficient output. The third one is the orchestration, which is the output is generated from the machine learning layer that is flow to the orchestration layer to make the application automate In this layer, we will automate the application using our result that we get from the machine learning layer. And apart from that, different kind of monitoring we used to apply based on the predictive analytics, and we do implement our system. We do automate our system, different kind of healthcare tools, different kind of healthcare supply chain also, logistics. So next slide is all about the foundational data layer. It's on the detailed implementation. What are the source? What are the data? Where it is coming? It is totally. I provide all the detail. If you see in that layer, data foundational layer, we taking different kind of system as a data source like ERP, SAP ERP, WMS, TMS, IoT, and external data. So these are all the data is not synchronized when we taking the data from different homogeneous systems. So inside the Azure platform, we use different kind of data migration tool, data synchronization tool to make the data before we pass it to the machine learning layer. We prepare the data, we cleanse the data. If you see the sources, all the sources are mentioned here. Then in the data factory, Azure data factory, we do ingestion and quality control. We do unified governance lakehouse, analytics ready storage that can be used for the next phase. And in the curated option, we unified government lakehouse and analytical ready storage along with the business ready dataset qualified for pass to the next stage. The next layer is the data quality and governance. This is a main prerequisite for any kind of system. Using Azure, we will do the different kind of steps and procedure where it qualify for the next stage using different procedure inside the data quality and government step. Like validation, there are different kind, might be different kind of validation like rule based check, anomaly detection, then data lineage we check, which is like catalog and access history checking, metadata tracking. And apart from that, there is another government automation is there, which include data quality rules as well as automated remediations. So these are all the steps. There are more than uh, 50 steps, which is measured for the data governance and quality. But I have mentioned few in my presentation. These are the basic steps that you need to apply before you go into the next step. Now there is the ingestion layer, varietal machine learning layer, where if you see forecasting and anomaly detection model as passed to that particular ML layer, then automated training and deployment happen, explainable for fair AI. So here all the algorithm, all the things are applied to identify the, to train the model using metrics and for metrics and accuracy. Some hyperparameter tuning used to done based on the model. And after that, in final stage of this particular model, we do validation, which is automatic deployment. And as I told earlier, also the reinforcement learning is coming picture, where after deployment, we tune the model in a particular loop. So these are all the process for the intelligence layer. Now I am moving to the next slide, which tells you all about the predictive forecasting. This predictive forecasting based on different kind of language, algorithm, machine learning language and algorithm, which based on I provide few samples, which include the time series as well as the deep learning model. There is some scenario-based planning also. There is some probabilistic forecast for risk or decision also. So if you see in the diagrams, so different kind of data are applied for long-running data. We apply time series and de-earnings. For another different kind of data, which is a near neighbor search, we use base case. So these are the different kind of algorithm we use for the predictive forecasting in the healthcare industry based on the Azure platform. The next one is the smart workflow orchestration, which based on the event-driven decision, policy-based automation, human loop escalation. There is other part also. So that these are the three major steps we can do to implement the workflow orchestration, which is a event-based, decision-driven, and based on the event and the decision, we do proper action. These are the three part come in picture and integrate together to provide orchestration and to implement the workflow and put the workflow in action in the different region, different part of the healthcare, like some medicine, preclinical trial, clinical trial. There is some medicine that for clinical trial, suppose some kit need to be transferred from Europe to America, Chicago. That kind of total orchestration using that workflow, it will automate the process so that the uncertainty of getting that particular kit on a proper time when the clinical trial starts, that will be eliminated and reduced so that all the things will be there now in the hand of the healthcare representative of the or the scientist in proper time. So I am giving this is on only one example. There is thousands of process and workflow that we can do using predictive analysis and Azure integration. So now there is preventive care as I telling. So it's better to prevent before the cure. So different kind of preventive care risk prediction, like we have different kind of tool, like some cancer detection, some kind of skin disease detection, and some kind of pattern, global border stone. This kind of thing we can predict, we can detect using predictive analysis, which the patient risk reduce and they can be treated early symptoms, and before that it can be. It also helps to different kind of proper statement and proper treatment one by one that can be taken while we have detected using preventive care. I am moving to the next one, which is the supply chain. Supply chain is a part of the uh, healthcare supply chain that where we will use predictive operations on the AI Azure platform. So where it comes in picture, where demand and disruption forecasting happening, where there is some demand of different kind of medical instrument, medical medicine, and different kind of medical human resources. This kind of supply chain predictive operation we used to apply over there, like demand on disruption forecasting, inventory and logistic optimization to make proper inventory inside the warehouse where it's nearby to the hospital or nearby to the operation or research center for that particular medical institute. So this kind of thing, if you see, there is different kind of steps like demand, risk and optimization. These three comes together and do different kind of part of the predictive operation, and we use implement different kind of other steps also to do and implement the predictive operations. Now I am moving to the next slide. As I told in the third slide in my presentation, that although we are applying all those prediction, implementation, analytics, and everything to get things better, to remove uncertainty and all the particular unavailability, but for a large enterprise application or large enterprise organization, security and compliance is the main and vital part. So everything, whatever we do, we must adhere to the security and compliance processes. So in healthcare system security and all the other processes also, so this architecture also helps to maintain those security in an optimized way. But we will not breach any kind of security in this architecture, and it will make more flexible on the security part. So that in any point, any person can check all the compliance part for a particular workflow which we implemented, that all the security part is maintaining, all the compliance part is followed or not. That way they can easily track the monitor that particular process to make the application and the particular organization more secure and more compliance. There is a different business impact, like it's faster, better for decision. There is some reduced operation risk and improved service levels. These are the different kind of business impact that ultimately, you know, related to the revenue generation and reputation of the company. So in the future decision, also it helps that organization, enterprise organization to get the generative AI copilot, cross ecosystem. These are the different kind of autonomous tool they are interested, so that they can direct their direction to some future improvement tools which I mentioned in that day, so that they are this kind of future improvement they can think of after they get that particular successful implementation of the AI for orchestration in the using Azure platform. This is all the future direction they can move, which I presented. The next slide, which present about the key takeaways, what we are getting insights from this presentation. So in this presentation, we can get that if we use those Azure as a platform, along with we integrate the predictive analytics used in different part of a healthcare system, which includes the supply chain of the healthcare supply chain, as well as the different part of the healthcare. It will not only faster, but it will compliance to their security and compliance process, as well as it will optimize different processes, which make ultimately gain to their revenue as well as the reputation. So that is all about from my end. Thank you. So any question?
Very good and very interesting to do with the healthcare. One thing I got there from you was Azure is best out of box
Right.
you can use for kind of applications like this. Definitely, down through the years, I've used different cloud platforms, and definitely I agree with you. Azure is the best out of box.
Yeah, absolutely. Yes.
Yeah. So we don't have any questions from the audience. Anybody on the call there have any questions?
No, nothing from my side.
Okay, cool. So this week is the first week I've been asked to play videos, so bear with me. Joseph, I can just see, I'll share my screen there first. And we'll see, can we get Joseph's video up on the screen then?
So then enable sound, just so the sound can be shared as well.
Okay, 1 second now. You see my screen there, yeah?
Yep.
Okay, so I'm just going to click into where the link then. I just paused for a second there, right? Can everybody hear?
I can't hear the video, Frank.
Can't hear the video. Do I need to go into something else?
I think there's I want to say there's a check mark when you share your screen.
So Frank, while sharing your screen.
Yeah.
Yeah, when you share your screen, there's an also share tab audio.
I'll just stop sharing for a second and I'll share again. So share screen.
And there's on that screen, there's a share audio, system audio or something.
So it says, yeah, it says follow the steps to share the video and audio, yeah?
Yeah, I think so.
Yeah. Okay, share screen present. It's given me okay, so I'll try that again. So also share audio tab. Is that the one, Dan?
Yeah, I think that's if you tell it to share the audio checkbox, that should if you're playing on a YouTube video or a video sound on your computer should get shared through it.
Okay, so we'll try it again. So
you can see your screen.
You can see my screen.
Mm-hmm.
Okay, cool. So we'll just bring that up and just go back to the start.
Hello guys, my name is Joseph.
Could you hear that?
Yep.
Okay.
So I am a Microsoft MVP and I'm very happy to come on the screen again today to walk us through agent settings in M365 Admin Center. In M365, agents can access data, automate activities or actions, and act on behalf of users. So controlling who can create, manage, or access these agents is essential to protect sensitive information and prevent misuse, and ensure that the agent operates securely and in line with organization policy, right? So agent setting M365 is becoming essential because if you check your Entra Admin Center, for instance, the list of your users, you would see a particular column there that will tell you is agents no or yes, right? So this means that agents are now classified under users, but of just a distinguishing factor here that shows if they are agents or not, right? So it becomes important that we are all aware that agent is coming with the same or even a greater force than AI is being embraced and utilized today. So there will be need for us to manage how we could allow agent usage in our environment and what type of agents do we want, right? So that's why when I picked up this document, I saw a lot of beautiful things that I need us to theoretically look at in the Microsoft Learn document and see how we can also go to the M365 Admin Center to bring up a lot that could also be of use to us. So the agent setting page in M365 is a very interactive page, but the overview, first of all, is that agents, you need to talk about the allowed agent type. So specify which categories of AI agents you want to permit in your organization, right? So we talk about the sharing. So you want to manage who can share the agent within your organization and define the method they can use to share these agents, right? So we speak about the templates. What templates do you want? You want to create a preset policy, the rules, and the allowed list for new agents to ensure consistency and also compliance, right? So talking about the user access, which for me is one of those very important things to look at because you really need to control which users or groups can interact with AI agents. So aligning access within organization rules and permission. So a lot have been spoken theoretically. Now it is time for us to look at the admin center. So if you look at the admin center here, if you are new here, it is, I've just clicked on home again. If you are new here, this is actually where you get to if you type in admin.cloud.microsoft or if you go with admin.microsoft.com. So if you have the required rights, you would see the agent icon here, and here you have overview, you have allowed agents, you have tools. But as our topic for today implies, we are talking about the agent settings. So we're just going to come into the settings icon here, and at this point you will see how to manage everything relating to agents. So these settings will include control to data access, to user permission, to integrated policies, and customization of agent behavior to align with your enterprise standards. So that's why this is very key, right? So if you come here, the first one is the allowed agent type. We specify which agent category, such as shared, external, permitted for use within your organization. Talking about the sharing, right? For sharing, you will want to manage who can share agents within your organization and define the method that they can use in sharing that. So if you come into the sharing parts, you will see that you can manage who can share, right? So you can decide to say, you know what, I want to allow everyone to be able to share agents, okay? So you can decide to say, I don't even want anyone to share agent, depends on you, or okay, you want to specify users or group that should be able to do that. So we are still going to look at this in detail when we go down to user access. Okay. So, and then for templates too, you can decide to create a preset policy, rules, and allowed list for AI agent. But what interests me a lot more is the part of user access, because of course, like I showed you from the Entra Admin Center, agents are now being embraced with 3 hands, right? Not even 2. So there will be need for you to be extra careful of who you want to grant access to agent. The reason is because agent has access to your data, and then it can automate actions, right? And it can do that on behalf of users. So you should be careful who you want to give access to agents to, right? So if you come to all users, which is the default setting that everyone is going to have access to, so long you have the Copilot license, right? So you can decide to say, even though you have the Copilot license, please, I do not want you to be able to create agent, right? Or we can decide to say, no, you know what, we want to specify users. So who can do that? You can decide to type in username, right? Just to bring the user up on the list, like adding one user, right? That is possible. You can also decide to say, you know what, you want to add group of people in a group that you want to give them allowed access to agents. I know I have group that is allowed agent, so I'm just going to create a security group from Entra Admin Center. At this point, I will want to just call it allowed agent 2, right? So because I know I already have created, during the course of my preparations for this video, I have created a group called allowed agent. So I'm just going to call this allowed agent 2, right? So, and I want to leave it as an assigned group. I can decide to make it a dynamic group, but that's not a topic of discussion for now. So I'm just going to copy this this group name, and then I'll just hit on create, right? Just so the group is created, and when I come to the the M35 Admin Center, I can decide to put in the name of that group here, and hopefully that's synced already, and then we can just bring it here. That means that you can put a list of users and groups within here. But I think it is better that you have your controls in terms of grouping, just so that your group is more descriptive, and then you practically manage the access to agents by adding or removing users from that group, right? So just click on save, and that is created. So this is important, that you manage users that should have access to agents, because of how sensitive it is for you to use. So while you are adopting AI, you are adopting Copilot, you're adopting AI agents in your environment, you should also be mindful of the integrity of your data, so that you don't have any form of data breach. So I hope this is educating enough. If you have questions, of course, you can drop them on the comment section, and I'm really very happy to engage with you and have the conversation around these topics. So I'll be dropping the link to this document also on the comment section, just so that you can have a look at the Microsoft documents that also discuss this topic. So I'll be saying bye from here, but I hope that we will engage more on the comment section. Have a wonderful morning, afternoon, or evening out there. Cheers.
That was cool, Frank.
Yeah, that's the first time now we had a recording.
That worked really well.
Yeah. So one of our other speakers, Samir, he's in India, and he booked it on Sessionize, but he sent me a video, so I might just play that as well.
Okay.
Because he was on the list. Be a bit of practice. Joseph, that was very good. And
The other thing you can do, Frank, is if you upload the video to StreamYard, if the video is short enough, you can actually just play the video and it'll go full screen in StreamYard and it'll mute all of us.
So
I think you do that under media assets on the far right.
Okay, so I'll just download it first.
Yeah, you have to download it, and then I think it's under video clips.
Okay.
And I don't remember what the length restriction is, but there was like a way to upload it as a clip. I know that's how Matthew used to do like the 5-minute or 3-minute breaks and stuff.
Okay, so I go into the media. Is that
we used to have on the Journey to the Cloud show? Yeah, I think it's media assets, and then there's a video clips area, and I think it'll tell you if there's room.
Oh yeah, I see intro and outro.
Yeah,
there's more.
Yeah, and I don't remember if there's a limit of like a certain length, and then there's also under the plus where you go to share your screen. There's a video file under there too. So I don't know if you need to upload it to the plus video file or to the intro outro.
Okay.
But it'll probably tell you what the length limits are too.
Hi everyone, thanks for joining me today.
There we
my
go.
name is Amir, and I'm the 2-time Microsoft MVP. Firstly in Happy Crowd and now in the Microsoft AI services. So today we are going to talk a little bit about monitoring Azure OpenAI service. Now this is going to be a quick introduction to not how to do it, because I think in a lot of YouTube videos or in sessions in conferences you may have already seen in the portal where to go, what to click, and how to configure things. But here I'm just to tell you some of the things that I've learned over the time from my experience or watching other people do it and learning from their experiences. So this is going to be a little bit of I wouldn't say theory, but a lot of discussions, prep. Let's call it the prep before you actually create or set up some monitoring. Now, that's what we're going to do. Agenda today is to discuss why Azure OpenAI monitoring differs. Gen AI monitoring in general is, if you're in this domain, you must have realized is not exactly the same thing. So we are going to discuss why and what. Then we are going to talk a little bit about the official Azure monitoring approach. Azure has an amazing observability platform called the Azure Monitor. So using that, if you're deploying in Azure, then it becomes easy for you to get started with your monitoring. But then we also have some gaps in this monitoring. So this ecosystem is constantly evolving. So we haven't reached to the end game yet. So we still have a lot to learn, and Microsoft also is trying really hard to give us the ability or the power to monitor our apps to the best, but still we are getting there. We're not there yet. However, there are some third-party tools and frameworks that are very widely accepted, and that they do enhance your capabilities, or give you the power to go a little bit deeper into your application or your LLM layers to monitor your telemetry. Then we are going to quickly discuss what the pitfalls and the real-world lessons that we are getting out of this from the experience of monitoring your OpenAI systems. Now let's talk briefly about what monitoring Azure OpenAI versus apps is like, just traditional apps, what that actually mean. So when we are talking about monitoring an application that is powered by Gen AI systems, then we are really talking about two different observability platforms or two observability systems. So one is the infra-focused, where let's call it the heart of the application, or the body, let's call it the body of the application is running. And then there's the LLM observability, where the brain or heart, or what do you want to call it, the brain of the application is running. And these things are different. So we've known for a while about the infrastructure monitoring, infrastructure observability, but the LLM observability part is a bit new for us, and we are still learning what to do and how to do it. And so when we talk about infrastructure metrics, we're really talking about things like VM uptime, CPU memory, network latency, error rates, just to make sure that we are, the performance of the application is reliable, and it is performant for all the users. Again, so we've been doing this for a long time. However, LLM behavior observability is quite different. So LLMs do have their unique personality, right? So every different model that you deploy, a different model that you use will behave differently and will respond differently to the same exact prompt. So from this personality, it also comes with a lot of nuances as to how an LLM system actually behaves, and how do we determine whether, if it's behaving correctly or we want to improve the behavior. So we monitor output quality, prompt effectiveness, and conversation flow, detect hallucinations, bias, content loss, context loss. So these are all the new terminologies, new concepts that we've had to learn since the LLM apps are being, are coming more into the market. Combined monitoring now, of course, when we talk about an application that is powered by Gen AI, we are not only isolated monitoring LLM, but we are also not isolated monitoring infrastructure. So we have to combine them together, because that is what the whole creates the whole application. And then strategic impact, how does this actually affect how the SLAs are to be defined and are to be maintained? How do we continuously improve these LLM-backed systems? How do we improve the UX? How do we improve the model deployment and the AI reliability, the responsible AI, and things like that? So traditional app monitoring, again, we just talked about, is our very CPU and memory focus, or CDM, CPU disk memory. They're talking about, is my CPU too much? Is my disk space too low? Is my network bandwidth not enough? Are my users getting like 4xx errors? Or is there any general slowness in the performance of applications? Right? So these are the things that we are talking when we are talking traditional monitoring. And of course, availability, a traditional application most likely would be either up or down. Now, obviously, there will be a component of resiliency and backup and things like that. But let's say I have a web app that is deployed on a particular endpoint. So if I hit that endpoint, I either reach the application or I don't. Right? So that is the uptime and availability aspect of it. And it's deterministic and it's resource-based, right? So deterministic in the sense that we know what to expect. We know what kind of input is going to be, acceptable for the application. So if it's not that, it is not going to accept it at all. We know how the internal processing of that input is going to happen inside the application, and we know what output, exact output that it is going to, produce. And all of this is resource-based in the sense that we know if CPU is high, the performance is going to go low. If we know that the latency is high, then the application is going to perform slowly. So it is resource-based. If I have ample amount of resources available to run my application, most likely your applications are going to run smooth, and they're going to run fast. And then tools and signals. So again, since this have been around for a long time, we have different ways to run traditional applications like the IaaS, PaaS, SaaS, things like that. So these platforms where you're hosting these applications, a lot of the times they are already equipped with their own ecosystems. Like in case of Azure, we have Azure Monitor. So if you have deployed your applications in here, it is automatically being monitored for the basic signals like CPU, memory, network. But on the other hand, the application powered by Gen AI has a different flow. So one, you've got the prompt submitted by the user or by another system or another agent, whatever. So once you get this prompt then let's say starts the Gen AI component of your application. Then these are converted into tokens, right? So tokens are the transaction units, let's say, for in the way that the LLM deals with the data. Whatever input that it receives, it is going to tokenize it. It is going to split it into smaller tokens and then process it. And then, of course, the cost generated is directly proportional to the amount of tokens that your application is providing. So in this way, also it is quite it's a bit different from traditional apps that it becomes really important to budget for cost right from the design phase of your applications. Now, there are some things to remember. The prompt size, of course, will matter. The bigger the prompt, more tokens you're going to have to process. And again, remember that the cost of an AI application depends directly on how many tokens you're consuming. So we have to be very careful of when we are talking about or when we are designing for cost. Make sure that your cost, you can reasonably predict what your cost is going to. Now you cannot obviously pinpoint to the exact number, but within the range. A response quality drift, this is another challenge that is unique to LLMs, that it is not always going to hard fail. It might just soft fail in many cases, that over time, slowly as your context accumulates. Now this context may be good, this context may be bad, but as this accumulates, it is going to deviate a little bit from the standard output that it is supposed to give you. So you have to make sure that you are evaluating for the response quality drift of your LLM applications as well. Now, how do we, in the context of Azure OpenAI in particular, how do we monitor these things? Now, Azure, like we said, already has a robust observability platform, at least when it comes to the infra side of it. So we've got Azure Monitor. And Azure Monitor does have Azure OpenAI telemetry for all the instances as you deploy it. It already has collecting some platform metrics. You can also collect additional logs using diagnostic settings and things like that. So it is as a baseline, you already have some data to go off of. Alerts and diagnostics. The Azure Monitor already gives you the ability to set up alerts at different levels of your applications, right? So you can set up for infrastructure, you can set it up for availability, you can set it up for performance, things like that. So you make sure that we have got alerts that are robust and that are distributed along the length of your architecture of your application. Dependency tracing, this is basically how you monitor the user journey, the sessions in your applications, and how is a user navigating your application, let's say, or which area of the applications is most prone to errors, things like that. So these are already logged into your distributed tracing in App Insights. And on top of that, you can also add custom telemetry. So this default telemetry works fantastic, but it is not enough. So when your application is super specific, you're designed to do one particular thing, you may want to have additional insights, additional telemetry to one operation, or just make it easier for you in the future to troubleshoot something, right? So if your application is verbose, then it becomes quite easy for you as a developer or as a troubleshooter to actually pinpoint to the exact error. Yeah, this is basically what we talked about. Native metrics limitations. It's not the best, but it does come out of the box. And so if you want to, it is very low effort, of course, since you don't really have to do much. But it also has its limitations in the case that it is, specifically in the case of AI apps, it lacks things like prompt versioning, which is just basically how your prompt evolves over time in your application, and then semantic context tracing, which is again basically how your the meaning of your prompt evolves along with the words that are used for prompting, right? So you don't really get any conversation level insights as well right? So if I, as a user, having a conversation with a co-pilot or with a chatbot, I will get a high-level summary of, okay, these many tokens were consumed in this application, or the user gave a thumbs up or a thumbs down to this application, or they, random things like that, or these tools were called, blah, 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 this was the latency, etc. But it is very basic. It is not going to give you, so it will give you at the session level, maybe at the highest, but it's not going to give you at the conversation level. Depending on how your application is hosted, or depending on where your agent is hosted, you can have it hosted on like Azure, if you're making it using AI Foundry or Copilot, things like that. But you can also host it, self on your self systems. So where you're hosting your application, your agents also determines what and how you can monitor it. And we talked about Azure Monitor quite a lot. So what are some of the other observability tools and frameworks that you can use? There are a couple of popular ones, LangChain being one of them. So now we are moving a little bit more towards the LLM observability rather than the infrastructure observability, right? So in the beginning, do you remember we talked about two components of observability for an AI system, which is the infra part, which deals with the application itself, the browser and the resources like the CPU, disk memory, network throughput, this and that. And then we have got things like prompt drift, response drift, tokens used, tool called, tool failure, and the things that are very specific to the functioning of an LLM. So LangChain is a popular tool for tracing the insights of your LLM application, right? So application insights will actually just treat an API call to LLM as like a simple single API call. And then it comes back with the response that the LLM system has given. But with LangChain, you can actually see what's been happening inside the LLM. So this will basically help you identify as to how many tokens are being used at each step of LLM operations, what is the cost at each step of the operations, and what is the latency, what is the where is the scope for improvement. You can do this using or you can rather monitor this or identify this using things like LangChain. And the other popular observability platform for LLMs would be LangFuse. This is again where all the I don't want to repeat it again, but all the metrics that are very specific to the processing of LLMs. This is where LangFuse is what you will use to monitor them, to identify the performance and to troubleshoot what's been happening inside the LLM rather than at the application level. So with all that, this is basically, again, I know this has been really, really quick. There's a lot more, much lengthier conversation that we can have about this, and hopefully we'll have it in a longer session, maybe like 40-45-minute session. But for this one, I hope I gave you some useful tips, some useful insights as to what makes in observability for an AI system, how it is different from the traditional systems, and what tools and what frameworks, etc., that you can use to monitor those. Just to give you a quick recap, this is a Gen AI specific focus. There are new terminologies, new things, new concepts that come into play when you are monitoring a Gen AI system. So we have to track the token usage, prompt patterns, model behavior beyond traditional app metrics. Extend observability, so you have to combine Azure metrics with custom telemetry and select third-party tools. Again, like I said, Azure Monitor is an excellent starting point. By all means, do start with that. Extend it as much as you can, and when you think you are at the end of customizability for Azure Monitor, or you are simply not getting the data that you want, which is hidden inside the LLM layer, then you go for other things like LangFuse, LangChain, and things like that. Mind the gaps again, identify blind spots of your application, some black boxes that you really don't have observability into. And then ultimately the outcomes to drive here are better cost control, higher response quality, compliance, and reliable deployments, right? So cost, the biggest challenge of monitoring an AI system, because again, remember that you can get different metrics, you can get technical numbers sort of a system, some telemetry, you can get it, but this is directly impacted by the number of tokens that you are processing. And so it becomes really, really important for you to control the model behavior, to control the input and control the output, and how we get there. And so these are just basically some things, some gotchas that you really should be careful about. But thank you again for joining me. Have a nice day.
That was great, Frank.
Yeah.
Okay.
That was first
I
time.
thought I wasn't hearing you.
two videos of people.
Yeah, that's cool.
The last guy, Samir, he's in India, and it was kind of like early 1 o'clock in the morning.
Yeah.
So it was.
That's what I was concerned about with Steven's last, the MVP or sorry MCT event that Opeyemi Steven did. It was on a day where I thought I was going to be busy, and I ended up just repurposing the video because I had recorded a video with responses, but then showed up in person.
Yeah. Very good.
Yeah.
So yeah, we're
great to see you.
So I'm just going to end the live stream. Thanks everybody for joining us. We'll be back here again next week. On the 30th, I think we have Precious is coming on, a woman speaker, next week doing her debut. So we'll be looking forward to that. So thanks everyone. See you again next week.
Take care, everybody.